Hi and welcome to a Groovy Apps tutorial, and in this particular video we are looking at how to get the most out of the Turbo Converter app. Just very briefly, the reason that I wrote the app in the first place was twofold. To make it as quick and as simple for you as possible to check all of the working outs that you will be doing with all of the tasks that you're set to convert decimal to binary and binary to decimal. And of course, if you're in key stage 4, that will also include converting numbers into hex and from hex to decimal and binary as well, because it can be a little bit tedious to bring up a browser every time you want to check your working out and to check your answers. The second reason I wrote Turbo Converter was to build your confidence understanding what the different numbers look like and the bit patterns which change when we do a left and a right shift, of course, and that's the reason why I have highlighted the ones in pink and the zeros in white to make the pattern stand out as much as possible for you, and I will explain a little bit more about that later on in the video. So getting the most out of Turbo Converter, let's start off on the left hand side with the dial feature. So what I can do with the dial is I can use it to reset all of my numbers to 0. And as I move the dial over to the right hand side and I generate decimal numbers all the way up to 255, you can see that a key feature of Turbo Converter is that the binary and hex equivalent of the decimal number is instantly calculated and made available to you. And you can see the pinks and the whites changing as well as the ones and the zeros and the bit pattern changes as we are progressing from 0 up to 255. Of course, when we get to 255, we've filled up all of our 8 bits, and the reason it stops there is because at both key stage 3 and key stage 4 you will not be asked to work with anything larger than a byte or 255, a decimal 255 equivalent. So that's why with Turbo Converter you won't be able to enter any numbers larger than 255 because you won't need to work with those larger numbers. Now, another useful feature of the dial, as well as being able to reset your numbers back to 0, is to randomly create numbers the way you can practice your conversion either from decimal into binary or binary into decimal, or to use hex as well. Simply by clicking on the scale around the outside, you can create random numbers for yourself. Now, if it's a question of actually working with a number that you've been given, you can use the dial to do that, for example. So there's 161, 164. It's a little bit tricky. You can use the spin box buttons to increment and decrement to make final adjustments, but the easiest way to work with a given number is to simply type it straight into the box. So let's imagine I've been given the number 120. What is the binary and hex equivalent of 120? And you can see straight away it's being calculated for you. So the binary equivalent of 120 is this binary number here, and the hex equivalent of 120 is 78. And once you've been given those, of course, you can check your answers, check your working out to make sure you've got the correct answer. Now, I'm sort of quite happy giving you an app which gives you the answer, because in reality with your assessments and your tasks you will be asked to show your working out. So the purpose of Turbo Converter is simply for you to be able to check your working outs, which you can also do using the pinks and the whites here as well. I'll talk more about that in a second, and to check you've got the right answer and that your working out gives you the correct answer that's shown with Turbo Converter. Now, likewise, you won't just be working with decimals. You may be asked to convert a binary number into decimal or to hex as well. So we can type in here the binary number we've been asked to convert, and you can see that it's dynamic. So as soon as I change the binary number in the box, then Turbo Converter instantly converts that to the decimal and hex equivalent. You can see those numbers changing. So let's choose 01101 and let's put in another one and fill up with zeros. So you can see here that if I've been given the binary number 01101,100, then the correct answer, if you've been asked to convert that into decimal, is 108. And if you've been asked to convert it into hex, then the answer is 6C. Now, likewise, we can also use Turbo Converter to check our answers for hex conversions. So in the hex box, let's imagine I've been given A6 to convert into decimal or binary. So I just type in A6 and it gives me the binary equivalent here, right, which is 101.00110, and the decimal equivalent of A6 in hex is 166. So in addition to doing straight number conversions, another useful feature of Turbo Converter is for you to be able to visualize and to practice doing binary shifts to the left and to the right. And one of the reasons why I've put the pinks and the whites in there is to make the bit pattern very, very obvious, so that you can see how that changes and moves up and down the byte when we do a right and a left shift. So I'm going to choose a slightly smaller number because it'll be easier to work with. So let's choose 1011. So you can see the bit pattern here represented by the pinks and the ones, it's represented by the pinks and the whites, makes it very easy to see what a left and a right shift looks like. Now you'll know from your theory that if I do a left shift on this binary number 1011, it will give me a new binary number by shifting these up one slot to the left, and that new number will be the equivalent of doubling the decimal number that I've got. So I've got decimal 11, which is the equivalent of this binary number. When I do a left shift, it will give me the decimal of 22. So let's check to see if that works. Right, watch the pinks and the whites change when I do a left shift. You can see that they've all moved up one slot. I've got myself a new binary number, and that represents 22. Likewise, when I move my bit pattern one slot to the left, I will get 44. And if I move it one slot further, I will get 88. And if I move it again, I get 176. And of course, the opposite is true if I shift to the right. So I will halve my decimal, so go from 176 to 88 to 44. And each time you can see the pattern of zeros and ones moving to the right hand side by one slot. Now, in addition, what Turbo Converter will also allow you to do is to work with odd numbers. I don't think you are going to be asked to do a right shift and left shift on odd numbers, but it is possible to do that. And the way that we do that is we take the integer part of the odd number when we shift it to the right, and we use that instead. And to show you what I mean, we've got decimal 11. Now, of course, in theory, what should happen if I right shift is that I will get a decimal which represents half, I will get a binary number which represents half of 11. But the problem is that half of 11 is 5.5, 5.5. And we don't work with decimal numbers in this way. So if I do a right shift, then Turbo Converter will give you a little message to explain what's going on. And it says, for this example of a right shift, half of 11 gives 5.5, which we can't use really. So what we do is we take the whole number part, the integer part, which is just 5, and we use that as our answer. And you can see on the screen that having done a right shift on 11, I actually get the equivalent of 5. So let me just type that in again. All right, so the bit pattern moves to the right hand side. Now what happens here is that this part of the bit pattern just drops off to the right hand side, and I'm just left with 101. So if I do a right shift, okay, I get not 5.5, but I get 5, and that basically is 101, because the rest of my bit pattern has dropped off off the edge on the right hand side, if that's the right expression. Likewise, if I do a right shift again, of course half of 5.5 is 2.5. We don't work with the fractional bit, so we will simply call that 2 rather than 2.5. So if I right shift, I will get the equivalent of binary 2, which of course is just 10. So let's look at the pinks and the whites in a little bit more detail, because you have seen this working right the way through the video. On the bottom of the app, I have the ones highlighted in pink and the zeros highlighted in white, or low lighted in white, I guess I should say. And that's to make it easier for you to see how the bit pattern changes as we're doing your calculations, and also a left shift and a right shift, but also to help you with the process of converting from binary to decimal and decimal to binary, because you will recognize that using our magic numbers 1 to 8, 64 all the way down to 1, and putting the binary equivalent of the number that we're working with. Okay, so if you're doing a decimal to binary conversion or a binary to decimal conversion, you will be looking to put your binary number underneath your magic number line. And what I've done is I've presented that to you whenever you type in a number for a conversion, and try to make it as clear as possible what those numbers look like. And in addition, I hope you can see this clearly on the video, but I've also done the calculations for you to check as well. So to give you an example of how this works, let's just use our dial. Okay, and let's just move it around a little bit. So we've got decimal 88. Decimal 88, right, if we were doing a conversion from binary to decimal or decimal to binary, we would look to write our magic numbers down, and then we'd look to write the binary number underneath. Now, I'm not going to go through the process in detail, the steps that we go through for converting binary to decimal and decimal to binary, because you will know what that looks like, and you will have seen this type of presentation of the binary number and the magic number before, and you'll recognize the calculation here where I'm saying 64 plus 16 plus 8 equals 88. And for every number you select, you will have a calculation provided for you, so you can check again your calculation and your working if you are doing a binary to decimal conversion, and the reverse of course as well. Okay, so I hope you found the tutorial useful. I hope you find Turbo Converter even more useful, and I might see you in another Groovy Apps tutorial.